Hey, all you cool cats and kittens. Let's learn about key features of a quadratic function. I've got them listed for you right here. So whenever you get to your assignment later today or tomorrow or whenever, these are the things that you're going to be looking for. All this right here. So it starts with domain, range, the vertex. We'll need to get some intercepts, the axis of symmetry, and this thing called concavity. And I'll walk you through all these. We got three different functions here to plot, and it's really not so bad. So let's go ahead and plot the first function and see what it looks like. Hopefully you remember from Algebra 1. I don't know if you ever studied these, but this shape, it is called a parabola, that kind of U-shaped function there. Again, it's just called a parabola. This thing, that is called a parabola. Anytime you graph a quadratic function, it's going to look something like that. So let's go through it. The first thing I will do is the domain. And the domain just means what are the x values that this function can take. And it's really simple for a quadratic function. This is never going to change. The domain is going to range from negative infinity all the way up to positive infinity. So the domain for any quadratic function is any real number. The range then is asking you, well, what y values can this function produce? So if you look at our y-axis, our function, it's going down, it's going down, it's going down. It reaches this minimum value right here, and then it bounces and starts to go back up again. So like if you notice, the y, or like the outputs, they never get down here. Like they never get to -5, they never get to -4, to -3, to -2. It does get to -1 though. So that's where our range is going to start. And how you'll write this out, there's kind of two different ways to do it. So our y value, as you can see, it can be anything greater than or equal to -1. But the other way to write it, kind of like how I did the domain up here, it ranges from, it can be -1, and it goes all the way up to positive infinity. And then that'll just be a parentheses because it's never actually going to get there. Okay, so the vertex is kind of like the turning point of your parabola. It's going to be either the minimum value or the maximum value, which again is just right down here. We do have a minimum value, it's right here. That point is at 1, 2, 3, then we go down 1. So that point is at 3, -1. Okay, so again, the vertex is just 1 point, and the location of this function's vertex is at 3, -1. The y-intercept, I know you remember talking about that whenever you did like linear functions in Algebra 1. It's just where your function crosses the y-axis, and that happens right here. This is my y-axis, the function crosses the y-axis right here. And that's a point as well. So the y-intercept is, the x-coordinate is 0. The y value that we were after is 8. So the y-intercept is 8 for this. The x-intercepts, there will always be 2 or 0. So the x-intercepts, where it's crossing the x-axis, we've got one right here and the other right here. And those are also points, just where your function crosses the x-axis. Our first point is at 2, 0. And we have another point, the point right here, that's at 4, 0. Okay, so x-intercepts get kind of confusing because there's a lot of different names for those. X-intercepts are also known as roots, and they're also known as solutions. So just keep that in mind. The axis of symmetry, it's not a point, it's a line. So like if you were to fold your parabola, where would it be symmetrical? And that's always going to pass through your vertex. So if you just kind of draw a shaded line through there or something, it's really easy to see. And again, it's a line. It's a line where x is always equal to 3. That's where this line, the x value is always 3, going straight up and down. And then concavity, that is just asking you which direction is your parabola pointing. So like if you start at the vertex, is your function going up or down? That's really it. So the concavity for this is concave up. Okay, this is just a real brief run through. Let's do another example, a different function. I'll walk you through this process one more time. So let me clear all this stuff. Let's get rid of that function. Let's put this one up and do it. Okay, so the domain for this function, I'm starting off with negative x squared right over here. The domain is, again, really easy to do. The x values can be anything for these functions. So the domain, it's going to range from negative infinity all the way up to positive infinity. The range, what are the y values? You can see this one is kind of hard to see, but here's my tip right here, right? That's my maximum value, whatever this value is. Luckily, I've got Desmos, and I can just give you the actual point. So the y value here is 6.25. Let me write that down. And the y value is 6.25. And it never gets higher than that. So our y value is always less than or equal to 6.25. Less than or equal to 6.25. And again, if you want to write that out using kind of this notation, that would be our y values range from negative infinity up to 6.25. Okay, the vertex, I already have it highlighted for you. Again, the vertex is just that maximum or minimum point, which is 1.5, 6.25. The y-intercept, where is it crossing our y-axis? That is right here. Again, that's a point, so that would be 0, 4, ordered pair. The x-intercepts, we have two of them, one right here, one right here. And those are also points. So our first x-intercept is at -1, 0. The other x-intercept is at 4, 0. The axis of symmetry, again, that's that line that the parabola can like fold over. I'll just kind of sketch a little dashed line for you so you can see it. Again, that's the axis of symmetry, always going to pass through your vertex. So that is x equals 1.5. And then the concavity. So remember, if you start at your vertex, are you having to move the function down or up? And I think it's pretty obvious here. If I start here, I'm having to go down. I'm going to go down this way, which means this is concave down. All right, fantastic. I have one more for you. Let me get rid of all this. Plot this thing. So we got 2x squared minus 14x plus 20, another quadratic function. I would definitely encourage you to pause this video and try to work through these all by yourselves and then see how I did it. So anyhow, let me go through it. Try to go a little quicker this time. So the domain, again, is all real numbers. Negative infinity up to positive infinity. The x values can be anything. The range, let's get where our y value is at. It's at -4.5. Okay, so the range, I'll just do it kind of the easy way this time. The range, our y value, can be anything greater than or equal to -4.5. Our function is never going to go below that value. The vertex, it's there as well, 3.5, -4.5. Another point. Our y-intercept, it's not graphed up here, like you can't see it, but it's pretty easy to find. You probably noticed the pattern on the first two that we did, but it's just going to be this number. So the y-intercept is going to be at 0.20. The x-intercepts, again, we have two of them, one right here, one right here. So those points would be called 2, 0. And my other point is at 5, 0. The axis of symmetry, that's going through my vertex right here. A terrible looking line, that's okay. The axis of symmetry is x equals 3.5. Then, hey, if I started at my vertex, I just kind of was like reading it like a book. I'm having to go up my function, so this is concave up. All right, guys, that's going to do it for this. Again, that was identifying key features of a quadratic function. Hope you enjoyed, and thanks for watching. See you in class. Goodbye.